Hi, in this project, we will build a machine learning model that predicts the confidence of forest fire happening, given the data as input. Now let's move forward. So what does this project entails? Forest, bush or vegetation fire can be described as any uncontrolled and non-prescribed combustion or burning of plants in a natural setting such as a forest, grassland, etc. In this project, we are not determining if a forest fire will take place or not. We are just predicting the confidence of forest fire happening. So, what I mean is that the likelihood of it being a forest fire is what we are trying to determine. It might look similar, but it is not. If I started predicting true or false for the forest fire happening, that means it is either 100% or 0% that the forest fire will take place. But in confidence says that there's 80%, I would say there's an 80% confidence that a forest fire might happen. It means that there's a likelihood or there's a probability of 0.8% that a forest fire will take place given the specific data for that forest fire. So moving forward, we now see at the details of the project. Now the project is divided into three parts. Building a machine learning model to predict forest fire confidence. We build a web app on Django to mount this prediction model. And lastly, we deploy this Django project on Heroku using GitHub or with the help of GitHub. So the machine learning model. We start off with building a machine learning model using random forest regression or random forest regressor model and train that model using the dataset that we have. For this project, we will also see the random search CV in action and how it is implemented. In brief, random search CV is designed to find the best parameters to improve your model. The search is randomized and all other parameters are held constant while the parameters we have defined are tested being them as variables. Meaning, let's say that a model has 7 parameters or hyperparameters and you have set 4 as them to have be a constant value and the rest 3 are set to be variables having some range of values. So the model random search CV, what it will do is it will just use those ranges for the 3 variables or the 3 parameters and choose which of the set of values for those 3 parameters the model works best at. So moving forward, we have Django web app, that is web application built on Django framework. This is the second part of the course where we will build the web application using the framework Django. We mount the model that we have built in the previous part on this Django project. Last part is deploying on Heroku, where we will deploy the Django application on Heroku using connections to GitHub. So with this, we now shall start the first part of the project, that is building our machine learning model. And even in that, the whole building machine learning model will be divided into two parts. First, where we will be building just the machine learning model. Next, it will be about how to use random search CV. So, this is the first part of the project where we will be building the machine learning model. And just like I said before, this part is also divided into two sub parts. First, where we will be understanding what the data is, how to use that data, maybe if we have to do EDA and feature engineering, what has to be done for both of these. In the next part, we will be understanding about how a basic model has been built using our random forest regressor, and after that you will see how to use random search CV. Now some of you must have heard about grid search CV. So both grid search CV and random search CV have the basic point of trying to exemplify or trying to actually make the model even better at predicting. That is by setting up the hyperparameters so that the model is using its optimum power to predict correctly. But the difference between grid search CV and randomized or random search CV is that one is like a brute force technique where you are just using each and every combination for all the variable parameters that you have set, while in randomized or random search CV, you, rather than taking each and every combination, randomly take any combination and see if it is actually giving you a better model or not. Okay, you will be seeing this in action in the second part of the first part of the project. So moving forward, we have the first block that tells basically that you have to mount the, see, it is written that drive already mounted. What it means to say is that my drive is now connected to this Google Colab, and this Colab can now access the files inside my drive. And this is done because I have kept the data set inside my drive itself. So you can even see that the drive has a dataset folder in which file archive or my dataset is present. This basically is the block of code where each and every package that I'm going to use is imported. So you can see that I've used date time. You will see later on why I've used this and what I'm going to use this for. The next is pandas, numpy, both again for manipulation of data or storing of data. And seaborn matplotlib, again both of these are for visualization of the data. Next you can see train test split, that is just the function for splitting the dataset into training, testing, or maybe validation also. And then the metrics, that is just to calculate the accuracy for the model. I won't be using classification report. If you want, you can look it up. And the last is importing the model itself. Now you can see that I've used the read CSV to get the data from the mounted drive to the Google Colab, and using the head function I can see the first 5 data points. So it has some of the columns, and what we are going to predict is the confidence that you can see here. So this is our target variable and the rest are our independent variables. Okay, so first we're just going to find out the shape or the cardinality of the data. Then we're going to find about null values. If you want to go even further, you can look up for ranges of the data. I would say the ranges for each of the columns, or I would say the outliers if they are present in some of the columns. Like for columns having numeral values, yeah, numerical values, you can see if there is any outlier present or not. Okay, so likewise, first we are just looking at the shape, and it has 36,000 data points with 15 columns, one being the target variable. And now using the is null dot sum function, what I'm doing is I'm trying to find out how many null values are present in each of the columns. From this you can see that there is not even one null value present. So I can say that this data or this data set is very clean in terms of null values. Next, I'm using the describe function. So the describe function gives me count, mean, minimum, the maximum, and quartile ranges for each of the columns that have integer or float values. Okay, so you can see that for latitude and longitude, the minimum is -42 and 114. The max is -10 and 153. So you can say that the ranges or the max and minimum are relatable or comparable for both of these columns. But you might see that for some of the columns, the ranges, like for you can say track, the minimum is 1, the maximum is 2. So the range is from 1 to 2 only, and it is not much comparable in terms of if I am trying to compare it with longitude or brightness. Okay, so why I'm actually asking you to look at it or have a glance at it is because sometimes it happens that the data set might have two columns where the range for one column is 1 to 10 and the range for other column is 1 to 10,000. Now these ranges are pretty far apart, and the model, when it works upon this data, won't be able to generalize well or won't be able to find particular good patterns which would help it in predicting the outcome properly. So for this what we can do is either use normalization on that column for the column where the range is 1 to 10,000 and shape it into a range of 1 to 1000 or maybe 500 or something, so that it becomes easy for the model to see that yeah, a value range for column A is between 1 to 100 and the value range for column B is from 1 to 500. They are nearly comparable, and the patterns that are built using that is much better at helping the model generalize. So for that, either you can do normalization or you can go for standardization. Both of these actually transform the column or columns into a better range wise and normally distributed wise, I would say. That means that the normal distribution changes and becomes more uniform once you do normalization or standardization on some column or columns, which helps the model again in generalizing well. So from here, not only can you see the minimum and maximum, you can even see the mean values for each of the columns. And this is basically the count tally or telling you how many data points are present for each of the columns. Okay, so the next part is where I'm trying to find the correlation for each and every data point, sorry, each and every column. Okay, and why I'm doing this again is because if two columns have too high correlation value, see the value range is from -1 to 1, both inclusive, okay, for correlation, and a high value is usually determined by the person, but a value range of say above zero point 0.8 or below -zero point 0.8 is usually very high. So you can see that the value is 0.98 for the columns track and scan. So this means that track and scan are very highly positively correlated or directly related. So what happens is if two columns are very much correlated to each other, then for the model they are bringing the same type of data onto the table, meaning that whatever track is providing to the model as data, something very similar to that type of data is what scan is also providing to the model. So if two columns are providing the same type of data, or if the two columns are providing something same or similar to the data to the model, then it means that one of the columns is not contributing much to the model. And while this is a very small data set in terms of columns, since there are only 15 columns, 14 columns present, we can keep the data or the columns as it is rather than removing them. But say if the number of columns present in this data set were 2000, now this is a very large value and the data set again also becomes very large. So for these type of situations, it is better to remove the columns that are not helping or contributing much to the model while training. So for that, I have shown you how you can remove or on what basis you can remove some of the columns to reduce the dimensionality and make it a little more easier and less computatively expensive for the model to train. But since the value is 0.98, even if the dataset is small, I'm still going to remove the scan or the track column. Now for me, I've considered that a value of 0.6 or 0. minus 0.58 is not that high, so I'm going to keep these columns also. For you, it might be high or you might think it is high, so you might remove them. So see, I have dropped the track column, and so next we are finding the categorical data type inside our data. So I've taken some of the columns just by looking at them and maybe determining that they might be categorical data type. So that is why I've taken the topic as finding categorical data. And from here you can see that the scan column has a value of 1 to 4.8 and each is occurring this many number of times. So the function value counts basically gives you a dictionary with all the unique data that is present in your column and the number of times each of that data, unique data, has occurred. So for some you might be thinking that oh my god, this is so many number of or this so if I try to convert it into a categorical data type or data column, it has a lot more than categories that I would like to put into a data set. Because if you know about get dummies or one hot encoding, then you know that from a data type or from a data column having some categories in it, we try to extract it by using get dummies or one hot encoding, where all of these categories become the new data columns and are having inputs as zeros and ones. So if there are this many number of columns that have to be attached to the original data set, then that would mean that there would be a very large number of columns present, which is not good. Because again, dimensionality, if it is very large, will make the model train on a very large time frame or very long time frame as compared to before. But then again, it does have a look of categories or categorical data. So I will tell you how to convert this into categorical data, which won't create so many or so large number of columns for us. The next, you can see that the required time is again having a lot of categories. So there are 662 categories. Again, we won't be using this because this can't be converted into a categorical data type where there's only maybe 5 to 10 categories present for all the data points in that column. But here, the satellite column only has two values, aqua or terra. So we can use this. The instrument column has only one data point or one unique data point, that is modest. So we're going to remove that. This since this is not giving me any type of information to the model for prediction, though it is giving information to us that the instrument is named modest. that is used for the forest fire analysis, but to the model it won't give any kind of contribution or any kind of importance. Again, the version has only one value, that is 6.3. We will be removing that. Then day night column. Okay, again day night column has two values, day and night. So again, this is a categorical data type or data column. So we will be using that. So I've given small pointers there, so you can just look through it also. So you can see that I have dropped the instrument and version. And now what I'm doing is using a function named map to map the day and night as 1 and 0 for the day night column, and the satellite column has 1 and 0 again for terra and aqua respectively. So what I've done is build a dictionary that I am giving as argument to my map function, and that map function is working on day night column first. So what is happening is in the day night column, the map function goes through each data point, and if it finds a d, then it replaces the d with 1. If it finds an n, then it replaces the n with 0. Same for satellite map also. And now you can see that the day night has converted from d or n to 1 or 0. Again, same for the, okay, where did it go? Yeah, satellite. So again, ones and zeros, not terra and aqua. So I've taken the type, since I got to know that the type was also a categorical data column. You can see that there's only three categories, 0, 2, and 3. So I'm using one hot encoding or get dummies function to extract that categorical data type. So you can see that 0, 2, 3. Again, we have built three new columns using the type data column. Now I'm just renaming the columns for better understanding. And you can see that the columns have been renamed now. So yeah, this is a little important part because I don't think many people use this, or I have not actually seen people using this much. So I've even set an brief about that. Now I've mentioned we will be converting scan column to categorical type. So we will be building this using binning method. So this is called the binning method, where we are actually defining buckets. Okay. And we know that the scan column had values ranging from 1 to 4.8. So I've defined bins or buckets. Okay, that 0 to 1 is one bucket, 1 to 2 is again one bucket, 2 to 3, 3 to 4, 4 to 5. And for each bucket I'm giving a label. So now I'm taking the forest scan column on which I'm doing binning and define my bins and labels. So once, say for the first value, the value ranges between 1.2. Okay, so it ranges between here. So you will give it a label of 1. So that is how it is done. So for each bucket, a label has been defined, and if a data point belongs to a particular bucket, then the mapped label is given to that bucket or to that value. So like in map function, each of the day and night was being replaced by zeros and ones. Here, each of the specific value is replaced by the label. And on what basis? On the basis of which bin or bucket that value is present in. So you can see that the buckets are now defined, and with that the labels are defined. Now you must have seen that we already have a date column. Now date columns are like again a type, or I would say in terms of usefulness they are very much similar to categorical data columns, because you can extract much information from date type columns also. And how we are going to extract information is what I'm going to show you now. But before going forward, I got to know that this is actually in a string format. Okay, so I've converted it into date format using toDateTime function. Now, what I'm going to do is I'm going to extract the year from this date. And you can see that I have built a new column named year and have filled it with the year from each of the dates. Similarly, I can do for month, day. So here date time package is being used. And not only month and day, I can even take out the week, the day of the week. Like for Monday it's 1, Sunday is 0, or even the similar like a week also, that it is uh, third week, fourth week, seventh week. So for a lot of more information can be extracted out, but for the purpose of this project I've just taken the month, day and year. So you can see that after removing and integrating more columns, we have come up to 17 columns in total. Now I'm segregating the target variable from my independent variables and removing all the columns that are now not required. So with this, I have again built a correlation graph to see if some of the new features that I've built using feature engineering, are they being correlated or highly correlated with any other column. Then I'm going to remove them also. But from here, not much is, or not much has been told or specified which would tell that yeah, two columns are highly correlated. But you can see that the year is not filled. For the column year, there is no value present. And it is funny, but the reason being is because year again has only one value to showcase, that is 2019. And that is the reason why this is empty. If there would have been different values like 2020, maybe 21, maybe 15, 16, then this would also have been filled. So again, if you want, you can remove the year because this is not contributing much to the model. And with the final, I would say this is the final data set that I would input to the model. So I'm just looking at it using the head function, and then I'm just using the train test split. But you can see that I'm just inputting the first 500 data points. Now it has 36,000 data points, but I am only using 500 data points. This is because 36,000 data points were taking a lot of time. In random fit, or I would say in random regress forest regressor, it won't take much time. But when you use the whole of the data set for the randomized or random search CV, it will take a lot of time. And I will show you that even for the 500 data points, it has taken around 40 to 50 minutes to find the best parameter. So you can just think about if it would have been 36,000 data points, how much time it would have taken. Okay, if you want, you can change the value to 1000 to 5000. It's your wish. But for this project, I'm just using the 500 data points. So I've shuffled the data points and then used the 500 data points. And from my random, so I've instantiated the random model, that is the random forest regressor model. And using the fit function, I'm training the model and I'm getting an accuracy of 95.32% for training, but again an accuracy of 65% for testing. That means the model has overfit. So what you can do is either use a simple model like maybe linear regression model, or try to dumb down or decrease the complexity of your data, meaning remove some of the more features or bring back some of the features that were easy to understand. Okay, so that it might increase the accuracy for testing. I haven't done that because I wanted to show you about how to use random search CV. So I'm going to cut this short and move on to the second part or build the second part where we are actually using the random search CV models. In this part, we will be understanding what is random search CV, why do we use it, and lastly, how to use it. So I'm using the getParams function to find all the hyperparameters for my model, that is random forest regressor. And you can see that it has given me a dictionary with all of the parameters and their default values. So from all of these parameters, I'm going to take some of the parameters and keep the rest as fixed, having their default values. So I'm using the n estimators, that is the number of trees in the forest to be formed, then the max features, max depth, minimum sample split, minimum sample leaf, and bootstrap. So these are the parameters or hyperparameters that I'm going to set as variables, defining a range for them and inputting them inside the random search CV to find an optimal set or combination of these parameters. Okay. So I've imported the randomized search CV from model selection, and you can see that now I'm setting the ranges for each of the variable hyperparameters. Now I'm creating a dictionary and send, which again would be sent to the randomized search CV. So here the n estimator is the list having numbers starting from 300 and the max value being 500 with 20 gaps, meaning that the first number is 300, then 320, 340, 360, and so on till 500. Okay, the max feature is the number of features that I have to consider at every split, and they have two values defined in random forest classifier or regressor. These are auto and square root. Then again, similarly, I'm defining max depth that starts from 15, ends with 37 with a gap of 7. That is, if it is 15, the next is 22, and so on. Then the minimum sample split, minimum sample leaf. So now I've set these in random grid or my dictionary that I'm going to send later on. And you can see that this is the final dictionary. Okay. So you can see that I've called the randomized search CV, have the estimator ready. That is my model, the base model. Then the parameter distribution, that is the dictionary that I built here. Then number of iterations that should happen for each, that is 50. CV is like epoch, that is telling you that number of iterations and number of time those iterations have to work. So in total we will have 150 cycles. Okay, you can see that there is a totaling of 150 fits to find the optimal solution. And again we are just shuffling the batches. So you can see that for 150 fits it has taken a lot of time and used different combination of parameter values. You can see from here. Okay, and yeah, just like I told you, this takes a lot of time. So if you have a data set that is quite large and you have a lot of parameters also, then just define those parameters that are getting you the solution or the accuracy that you want. Rather than setting up each and every parameter, just set up those specific parameters that you know will actually change the outcome or will actually increase the accuracy for the model. Now see, you can see that there's 53 minutes. So after 53 minutes it has completed its execution, and when I type best param, so it gives me the best parameter for the random forest regressor. Now I'll just build a new or instantiate a new random forest regressor object, give it the input of best params and fit again, and you can see that there's only an increase of 68, okay, increase of 3%, nearly 3%. So this might not look much, okay, and the reason being is that the ranges that I defined in here are actually just randomly set up, meaning I didn't know that for a range of 300 to 500 would be a good value for the classifier or for the regressor, or a value of 15 to 35 would be good. I've just set it up so that it can give you an example and or an overview of how to set the parameters and their ranges and how to input those parameters or with their ranges to the randomized search CV. You can change these values and see if it gets even better or the accuracy increases. Okay. So with this part, I would like to end the building a machine learning model. So I'm going to use this model that I have trained since I've already saved this. Okay. Another thing to notice here is that once I saved this model, it was saved on disk with a size of 500 MB. Now 500 MB is a very large file. If I have to implement that in a web application and then deploy it on a service like Heroku, which gives the 500 MB of disk size on server. So I can't use Heroku, at least not the free version of Heroku directly. So what I've done is I've installed a library named bz2 file. This is basically a compressing library, meaning that it has functions created in it that helps in compression of files. So you can see that I've imported bz2, and with a compression level of 9, this is the default value. What I am doing is opening my forest model pickled file and compressing it, and then saving that compressed file into a forest model.bz2. Okay, so what I'm going to do now is directly use this rather than this. And why I'm going to do this is because my compressed file actually went, okay, you can see that the, yeah, now the pickled file was over 700 MB. Okay, sorry, it was not near 500 MB, but had a size of 700 MB, and after compression it went to 93 MB. So I can use this because 93 MB again is very small as compared to the disk space of 500 MB that is given by Heroku. So I've just saved this file, and this is the file I'm going to directly use inside my web application also, which I'm going to show you, okay, in the next part. So with this, I'm going to complete the first part and hop on to the second part, that is building a web application using Django. So this is the second part of the project where we are building a web application or setting up our web application that is based on or built on Django framework. So before we directly move on to the code and understand what is happening, first we have to set up the code. So for that we have to implement some of the pointers that I've shown here. Okay, so the first thing you have to do is create a project directory. Now I've named the project directory forest fires, and inside that you have to build a environment for that project, meaning you have a project directory inside where you are going to specify the code or keep the code, and to run that code you need to first create an environment so that all the packages and the dependencies are installed in that environment only. Okay, so if you're using PyCharm or any of the IDE, you can basically go into your files or maybe settings, and in that settings you would be shown to go to project interpreter, or maybe go to the environment, or there's an option for building an environment. So you can do that. Okay, go to your wherever your environment is set up or built, and then build that environment for the project. If you don't have any ID, or you're directly handling all the code from the console, then just go to your console and type in a command for building the environment. So once your environment is set up, what you have to do is just run this command. Okay, before running this command, just put the code inside your directory that you built, and then go to the my site. So in your terminal, go inside the forest fire directory, or maybe whatever directory you built, then inside my site, and run the command pip install -r requirements.txt. Once you run this command, then all the packages and dependencies that are needed by this project will be downloaded and installed, and then you can start running the project or this code. Okay, so once you do that, the next thing to do is type in python manage.py migrate. Now this code is particular to Django. This is not an Python related. It is a Python related code, but it is used in Django for creating and setting up your database. Now, just like I told you, Django gives you a base app, or I would say a base project, on which you can add more and more things to build your web application. So in that base project, it provides you with some of the tables in your databases that are required for maybe authentication, for maybe storing files or something like that. So that those database tables have to be instantiated. For that, we run the python manage.py migrate. Or if you have upgraded your code, or if you have added something new, or maybe some new tables for your databases, then again you have to run that migrate code. So lastly, what you have to do is run python manage.py run server. This is when all of your code has been defined, set up, and or maybe upgraded. Okay, so once you run this, it is going to take a little time to start the app, or to run the app locally, and you can see that once it starts, it is showing that starting development server at your localhost URL. So once you click on it, then so you can see that the page is now loaded, and you just have to type in your data and click on confirm submission. Like if I type on the data, say, now this is not looking very good in terms of web UI and such, because I've just pasted it a basic form and just created that form so that I can look if my model is actually working or not. So you can see that it has now taken in the data, and it is loading the model and inputting this data into that model, and then it would return you the result, which will be shown maybe here in the last part. Okay, but before I move forward, see, this is taking a lot time, and this is because what we have done is that we have taken the pickled file and we have also compressed it. So now that compressed file is first taken, or maybe uncompressed, and then that pickle file is loaded into the model. Or I would say the pickle file is loaded as the model, and then the data that we have input here is taken, and the prediction is done. So this is taking a lot of time. I don't know why, but maybe going back, yeah. So you can see that this is the views.py page. Okay, so this page is actually present in my polls directory. But moving forward, before we move forward, These two are the basic code, I would say the basic execution command from which we can build the project, Django project, that is our base project, and we can build an app inside the project. So this my side is actually the project that was built, and this polls is actually the app that I have built, for which from where I would run the or render the templates or the HTML files. So for each app, there's only one views from where you can manipulate the data, store the data that is coming from the front end, use the data that is in the, okay, so yeah, maybe it has, yeah, so you can see that the confidence score is 86. Okay, that is basically telling you a likelihood of 0.86 is the value that it has predicted for all the input that I sent just now for the forest fire. So there is a chance of 86% that a forest fire might occur. Coming back, you can, yeah. So what I was telling you about was that a view is particular to an app, and inside the views, if you have set up a function which is taking a parameter request, then that function is defined for one HTML page, meaning this function is responsible for rendering the page and handling all the data that is related to the page. If you see, I have defined an index.html page which has a form in it, which we just had seen also inside our browser. So this form is taking data, okay, and that data is being given to this function. So I'm storing that data in a lot of variables that I have created, and then you can see that I'm creating a data frame and storing that data inside the data frame. Now that data frame is now being given as an input to my load, that is pickle load file, and then, okay, not pickle load file, to the predict function, okay, of the loaded model. That is the pickle file that I load. See, you can see there is a function redirect that is taking an input of home page, and then there's a render function. Okay, so this render function is what is responsible for rendering your page. Okay, so this function renders the index.html, and if you have to send the data from the front end, sorry, from the back end to the front end, then you can send it using context, that is a dictionary. Okay, so I'm sending a dictionary which is also called context in this reference, and the result is storing the final value or the confidence value. Okay, now you can see that there is also a small function defined named helper, but this is not taking a request. Now, if a function is not taking request as its parameter, that means that this function is not responsible for rendering any of the pages, and this function will work only when a call has been defined for this function. But a function that is taking request as parameter will always be called again and again each time the page, or I would say whenever the browser is refreshed. So this is the basic difference between the two functions. One is a basic function that is maybe a helper function or used for some particular case, and another is a function that takes in request as its parameter and is responsible for rendering a page or an HTML page. Okay, so you can see that how the data has been input from the front end, how the data goes into the back end, how the manipulation or use of that data occurs, and then how to send back result from my back end to the front end. Now let's go forward and look at settings.py. This is also another very important file because this is what handles or oversees the Django project. Now settings.py file is actually present inside your my site directory here with the URLs and WSGI files. So if you have just built an or instantiated an Django project, you can go to the docs and see how to do that. I have already given you the code. If you run it in on your terminal, it would create an basic Django project. But if you want to learn more about it, you can just go to the docs. It is pretty much clear and very easy to understand. But what you need to understand is that if you have just created a project, the debug would be on true and allowed host would be empty. This is because Django thinks that you are just now working on only development server, not on deployed servers. Okay. But if you're going to deploy your code, you have to turn this to false and you have to set up your allowed host so that it knows or this Django project knows on which DNS servers it has to run on. So this is so that you can run the app locally. This is where you are going to deploy the project. Now I'm going to tell you later on, that is in the third part, where did this come from. Okay. Next thing you should know about is static root. Now Django already provides you with static URL, but you have to manually set up the static root. This is required when you're going to deploy the project because servers don't understand that each and every app might have different kinds of static files. And by static files, I mean CSS, JavaScript, and images. Okay. So what we have to do is set up this static root so that the server understands that I don't care wherever those static files are present. You just have to pull all of that files and keep it inside the static files directory, and that server then would just refer to the static files directory only. So you have to set this up whenever you're going for deployment. Okay. The next thing you should know about is that you will be looking at a lot of abstract things like middleware, installed apps. So these apps are what I defined, and these apps are what Django itself defines. See, I told you that Django takes a lot of care for the user, and the user doesn't have to code each and everything itself, or sorry, himself or herself. And Django just basically provides you with these. What you can do is add or maybe append in it. So I've just added my own app, that is polls, and in the middleware you can see that Django is already taking care of security. It is already taking care of sessions, how sessions work. It is already taking care of Sierra CSRF tokens. So you can see that even it is taking care of authentication. So Django takes care of a lot of issues that usually on other applications you have to code it yourself. So with this, I'm going to finish the second part of the project, that is building our web application. Okay. And I'm going to move to the third part now and showcase you that some more files or commands have to be built or implemented before we can just simply jump off to production. Okay, so let's go to the third part. Part of the course where we will be deploying our web application on Heroku. But before we start with Heroku, we have to use some files which are like commands for Heroku to understand. So let's start with runtime.txt and proc file. So in runtime.txt, you can see that I've defined Python and the version for it. So runtime.txt is basically just telling Heroku which language or base is to be used by the server and the version for that. The proc file on the other hand that you can see here is the mechanism for declaring what commands are to be run by your application in Heroku platform. The commands that are specified in the last part, like server, run server, or migrate, you know, the python manage.py run server or python.manage.py migrate. There are even more commands for Django, and some of those are to be run before you can use the code or before the server can actually use the code and deploy your code online. So these commands are executed in Heroku's server using the proc file itself. Okay, so once you have instantiated or built the proc file in runtime.txt and have defined a requirement.txt file, you can now shift or you can now push the code for production. So what you have to do is first go to your GitHub, okay, and in GitHub just build a new repository, and inside that repository store this code. So if I go and write GitHub, so you can see I've already set up an repository and have the code inside my master branch. Okay, you can see the master branch here. And you can see another thing that is telling me there's an environment setup and it is active, which is telling me that the Heroku is using this repository and has set up the code and is now running on a server. So go to your Heroku platform or maybe just log into your Heroku account and click on new and create an app. Okay, once you click on create an app, it will ask you to name the app and then just go and click on create app. So you would be redirected to your dashboard, since this is my dashboard, and the app name would be shown here. Now you can see I've already built an app. So I'm going to click on it and then it would give me some settings or it would give me some options to make changes in my app. First, just go to your settings, okay, and in settings here click on add build pack. Once you click on it, it will ask you to choose one and you can choose the Python build pack and click on save changes. Once you do that, it would show you Heroku Python is now the build pack that would be used for this app. Go back and click on deploy. Inside deploy, if this is your first time using Heroku, then just click on GitHub Connect. Okay, so it will ask you to log in to your GitHub account, and once you do, it would set up that the GitHub account is now to be used with this app of the Heroku. Then it would ask you to write down a name of the repository that has to be connected with this app inside your Heroku account, and a connect option would be shown here. Once you click on connect, it would show you something like this. For me, it is saying that connected to SIDP, that is my account, Forest Fire, that is my repository. Okay, so once you do that, we have to go to the manual deploy. You have to not do the automatic deploys unless you know how to build a CI or you know how to build your, if you have knowledge of DevOps. So go to your manual deploys and click on the branch that has your code. Since mine is stored in master, I'm going to choose the master branch and click on deploy. Now this is going to take a lot of time and depends on person to person. Okay. But what this does is basically sets up your server and ask your server to use the Python build pack. Okay, then ask the server to use the specific version of Python that I have specified in the runtime.txt that you can see there, using Python version specified in runtime.txt. The next thing it does is installs all the dependencies and packages that are required by the code which was specified in your requirement.txt. Now it is collecting all the static files and storing it into the static files directory inside your server. Okay, so you can see that it has done a lot of work, and once all of that has been completed, it compresses the file and push the all of that files and code to the server, and then it would tell you that the server is now ready to be launched. And once that is completed, see, it is launching the server. So once that is completed, it would show you some tick marks for release phase and deploy to Heroku, and a view button is now shown. So this is taking a little more time, but once this is completed, and I'm waiting for it to get completed. Yeah, so you can see that the views button is now accessible, and if you click on it, you would be able to see the page. So just input anything, whatever you want, and just click on confirm submission. And after some time, since it takes a little more time to load and give you the result, it would then give you the result. Okay, but it might happen for some people that this would give you an error, meaning if you run the app, it would run, but once you click on confirm submission, it would give you an error telling you that the server may be crashed. And the reason for that is because free version of Heroku app doesn't give you much memory space, okay? And to run this code, it needs a little more memory space than the average small projects that are required. So what you have to do is just upgrade your Heroku account, okay, and just use a little more memory data that is provided to you. Say maybe a 200 MB or 500 MB data is provided. So just upgrade it to maybe a 1 GB or a 2 GB data RAM space, okay, and the code would run. If you are getting an error, if not, then it's fine. So with this, I'm going to finish off with the last part of this project, that was deploying the code on Heroku. And one thing that I have forgotten to specify was that how did I get the value inside my allowed host? Yeah, so you can see that there's the value here present. So how did I get that? Actually, once you create an app inside your Heroku, this option of open app is present there. So once you click on it, since I've already deployed the code, it is giving me the page. But since you wouldn't have been deploying the code, so it will give you at the default page of Heroku, giving the value, giving the this URL. So just copy this URL from here and paste it inside here. Okay. So this is how I got this value. Okay. So yeah, this was the last thing that I wanted to tell you about. And with this, I have completed the course, the project. Okay.